Alright, today we're going to talk about inscribed angles. Inscribed angles. And an inscribed angle has a vertex on the circle and sides that are chords. An inscribed angle has a vertex on the circle and sides that are chords. So a couple of pictures of an inscribed angle. In this circle right here, this is an example of an inscribed angle. Its vertex, point B, is on the circle, and its sides, side AB and side CB, are both chords. Okay? Another inscribed angle. Angle MNO. Okay? MNO is an inscribed angle. Its vertex is on the circle, and its sides are both chords. Alright, so now a couple of rules regarding inscribed angles. Alright, this is the inscribed angle theorem. And it states that if an angle is inscribed in a circle, then its measure is 1/2 the measure of its intercepted arc. If an angle is inscribed in a circle, then its measure is 1/2 the measure of its intercepted arc. So if you go back up over here and you add a little bit, add a note to this first example of an inscribed angle, you can say that the measure of angle ABC is equal to 1/2 times arc AC. The measure of this angle right here, that angle measure is equal to 1/2 of this arc measure. That's true for all inscribed angles. So the measure of this angle right here, that angle measure, angle N, angle MNO, is going to be equal to 1/2 of this arc. Okay? So the measure of angle MNO is equal to 1/2 times arc MO. Everybody got that? So turn the page, look at example 1 on page 724. Page 724. You've got a circle here. You've got some inscribed angles in there. And you're asked to find. And the first measurement is the measure of angle P. And then you're asked to find the measure of arc PO. Alright, pretty straightforward right here. Find the measure of angle P. Angle P is right here. Its vertex is on the circle. Its sides are chords. The measure of angle P is going to be half of its intercepted arc. Well, its intercepted arc is 70. So the measure of angle P is going to equal to 1/2 times 70, which equals 35 degrees. So this angle right here is 35 degrees. Now look at this, because the book doesn't specify. This angle, this inscribed angle, is always half of its intercepted arc. Okay? So in the next question, you're asked to find the intercepted arc. The measure of arc PO. So if the angle is half of the arc, isn't the arc twice as big as the angle? You see that? So if this inscribed angle is 56 degrees, then wouldn't the measure of arc PO be equal to 2 times 56, which is 112 degrees. So this arc would be 112. The angle is half the arc, and the arc is twice as big as the angle. Let's take a look at that second example in that box. You've got this circle, ECDF, E to C, up to D, down to F. And you've got this 40-degree angle right here, a 98-degree arc, and you're asked to find the measure of arc CF and the measure of angle C. Angle C would be right here. The measure of angle C ends at point D and at point E. So this red arc is its intercepted arc. So the measure of angle C would be equal to 1/2 times 98, which is 49. Arc CF. Arc CF sits right here. C to F. Arc CF is created by angle D, which is right here. If angle D is 40 degrees, arc CF would be 2 times 40, which is 80 degrees. So arc CF is 2 times 40, which is 80 degrees. Everybody all right with that? Any questions on what we've covered so far? Very good, very good. Take a look at Theorem 10.7 down on the bottom of page 724. 10.7 down on the bottom of page 24. If two inscribed angles of a circle intercept the same arc, or congruent arcs, then the angles are congruent. If two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So a picture of that would look like, let's take this blue angle, got an inscribed angle, call it DBC. And then we're going to put another inscribed angle in this circle that intercepts the same arc. So if we start at D again, but we just go to a different point on the circle and end at C. And we'll call that A. The red arc and the blue arc. I'm sorry, the red angle and the blue angle. They both intercept arc DC. That means the red angle is equal to the blue angle. Okay? So if the red angle is 2x plus 15, and the blue angle is 3x minus 5, and you're asked to find the measure of angle A. Find the measure of angle A. If both of the angles intercept the same arc, then the angles are equal to each other. And if the angles are equal to each other, then 3x minus 5 is equal to 2x plus 15. And you can solve for x. You can subtract 2x from each side. So your x minus 5 would equal 15. And then you could add 5 to each side. And your x would be equal to 20. If your x is equal to 20, and you need the measure of angle A, well, the measure of angle A would be equal to 2 times 20 plus 15. And 2 times 20 plus 15 would be 40 plus 15, which would be 55 and degrees. Any questions there about angles intercepting the same arc? Okay. Another picture of that, you don't need to write this down, but it may look like this. In the same circle, let's say that you've got an inscribed angle here, all right, and another inscribed angle here. Now, they don't intercept the same arc, do they? All right, you've got this arc and this arc. But if you're told that this is 40 degrees and that this is 40 degrees, okay? Now you've got two inscribed angles that are intercepting congruent arcs. So if this was angle A and this was angle B, angle A would be equal to 20 and angle B would also be equal to 20, okay? If they intercept the same arc, they're congruent. If they intercept congruent arcs, then they're also congruent. Alright, so here's some practice problems to do for you today. I want you to start on page or go to page, let's see, 727. You can do 1 through 6. And then 11 through 20. 1 through 6 and 11 through 20. Do it on a clean sheet of paper, please, so if I collect it tomorrow, you still got your notes in your notebook.